This creates a need for interplanetary diversity if the human race is to survive at a Type 1 level of civilization. Abundant energy will likely become either very cheap or completely free, accessible to everyone. The environment will benefit from reduced pollution thanks to the heavy reliance on renewable energy sources. Cities will become smart and efficient, with automated systems managing everything from traffic to energy use. Communication will become instantaneous and seamless across the globe. Space exploration will also likely expand significantly, with technologies such as solar power plants in space expanding our access to energy beyond Earth. Philip Meer, a planetary scientist and co-founder of the Planetary Resources Program, predicts that nuclear and renewable energy alone will not be enough to power the Earth as coal and oil run out. Meer suggests that humanity should embark on a 100-year project to develop space mining operations and spacecraft in space, such as asteroids or the Moon, to bring back the necessary materials to Earth. However, before we can harvest the resources in space, one of the few solutions we have is to develop and safely use nuclear fusion, which offers almost unlimited clean energy. A Type 2 or solar civilization on the Kardashev scale is one that has the ability to harness and manage the entire energy output of a star. This is a necessity that stems from the fact that relying on the energy naturally available to their planet and its natural resources will not be enough to support advances in technology and science. One of the most famous concepts for achieving a Type 2 civilization is the Dyson Sphere, proposed by theoretical physicist Freeman Dyson in 1960. This hypothetical megastructure is built around a star and aims to capture its entire energy output. Although designed as a solid shell according to popular science fiction, a more practical approach would probably be a Dyson Swarm of solar energy harvesting satellites orbiting the star. With this energy, a Type 2 civilization could support massive industrial projects, feed extremely large populations, and begin large-scale space colonization across solar systems. In such a civilization, daily life would be completely transformed. For example, interplanetary travel could become routine. As air travel has become routine for us, this could enable humans to live on different planets or in giant space habitats. Humans could live in rotating space habitats called O'Neill cylinders, which could create Earth-like environments that could house millions of people. They could also use theoretical stellar manipulation, called stellar engineering, to optimize the orbits of planets for human use, engage in large-scale asteroid mining, or extract resources from gas giants. Another interesting possibility is that Type 2 civilizations could create artificial stars or smaller controlled fusion reactors that mimic the processes of their stars, thus extracting more energy. A Type 3 or galactic civilization on the Kardashev scale is a civilization that can control and use the energy output of an entire galaxy. This type of civilization can harness the energy of billions of stars, or even extract energy from black holes or other cosmic phenomena to meet its industrial needs. One of the key concepts associated with a Type 3 civilization is galactic scale engineering. This is a theoretical concept that involves building megastructures or manipulating star systems throughout an entire galaxy. This could involve creating massive structures such as Dyson Spheres around multiple stars or entire star systems. The civilization could also build stellar engines that can alter the motion of stars or alter their energy output. With this immense energy, a Type 3 civilization could power technologies that are beyond our imagination, such as wormholes for superluminal travel or planet-sized computers that can simulate entire universes. Additionally, a Type 3 civilization could harness the rotational energy of black holes through a process known as the Penrose process. This theoretical method allows an object to be sent into the ergosphere of a black hole, splitting the energy and capturing some of it. They can also use Hawking radiation, the theoretical radiation emitted by black holes as they evaporate over time due to quantum effects, as an energy source.